Here's a GMAT quant question which explores this idea of average speed, and this might be useful if you're also doing, if you're studying physics and if you're doing kinematics. There's a lot of things and problems actually related to average speed there as well. So if you'd like to see anything similar to this, let me know down in the comments. So here's what we have. We have 2 points which are, let's call them A and B. And the question tells us that on a partly cloudy day, Derek decides to walk back from work. And when it's sunny, he walks at a speed of s miles per hour, where s is an integer, so this is quite important. And when it gets cloudy, he increases the speed, so he travels faster at a speed of s plus 1 miles per hour. And what we know is that the average speed is 2.8 miles per hour, and the question is, what fraction of the total distance he covered when the sun was shining on him? So let's try it this way. Let's say that the total distance traveled is from A to B, and let's say there's a point C somewhere in between, such that from A to C it's sunny, and from C to B it's cloudy. So what happens here is that Derek travels this distance with a speed of s, so he's enjoying the weather, not taking his time, and then when it's cloudy he increases the pace, he moves faster by 1 mile per hour. And we have to use this and also the fact that s is an integer, as well as the fact that, of course, the average speed is 2.8 miles per hour, to find what fraction of the total distance he covered when the sun was shining on him. In other words, we have to find this, AC divided by AB. And what is this? What value this has, and we have a few options to choose from. Right, so to do this, the first thing I would write is the formula for average speed. So average speed, let's say V with a dash on top, is the total distance divided by the total time. Okay, so it's AB, that's the total distance, and the total time, I'll just call it T. Okay, we don't really know what that is yet. So let's do it this way. Let's first find the time it takes Derek to walk from A to C. So this is going to be time T1, and then there's going to be another time T2 between C and B. Okay, so here's T1, which is distance, which is AC, divided by the speed. So we know that when it's sunny, he travels with a speed of s, so that's going to be divided by s. And the other thing is time t2 is the time it takes to travel through the cloudy part of the region. So that's going to be cb over the speed when it's cloudy, which is s plus 1. So that is it. So we obviously know that the total time is the sum of those two times. So we're going to take this and we're going to put it back in this equation for average speed. Now we can actually replace average speed with 2.8 miles per hour, because we know the problem gives us that information, so we might as well use it. So 2.8 equals, and then we have AB. Now instead of AB, what you could do, or actually let's leave AB as it is. I think it works better like this. So it's AB over, and then we have T1 plus T2, but instead of T1 plus T2, we're gonna first write what T1 is, which is just AC over S, and then plus T2, and T2 is CB over S plus 1. Now, I'm not going to write CB. What I'll do instead is I'll write, instead of CB, I'll write AB minus AC. So this is the same as AB minus AC over S plus 1, and you'll see why I do that. I'll explain in a second. So AB minus AC over S plus 1. Right, so the reason why I removed CB from everywhere, right, because everywhere you look now in this equation, I have AB, I have AC, and then AB and AC, is because the question is actually asking us to find this AC over AB. So what I'll then do is I will, first of all, let's call this X, just to make things a bit simpler. And the other thing I'll do is I'll divide the top and the bottom of this equation by AB. So this is what I have. I have AB over AB. And then I have AC over AB. Remember, we have to divide, if we divide here, we have to divide each and every term. And then we have plus, and then AB minus AC over AB times S plus 1. So it looks like it's getting a bit complicated, but not really, because now we know this is 1. We know this is, we called this one X earlier, and then we'll do something about this in a second. So this becomes 2.8 equals 1 divided by X over S. Maybe I should write on the next page. So 2.8 equals 1 over, and then X over S like this, and then plus. Now we divide each of those by AB. So AB over AB is, of course, 1, minus, and then AC over AB is X, and that's divided by S plus 1. So we sort of simplify this, and now we just have X, which is what we're trying to find, and then we also have S. So let's try to find X from here explicitly. So what I'll do is I will amplify, well, I'll bring things to the same denominator basically. So we have 2.8 equals, and then here I'll have S times S plus 1, and here I'll have S plus 1 times X plus S times 1 minus X. So we've got S times S plus 1 over, and then I can expand the brackets and I get Sx plus X, and then plus S minus Sx. So the good thing is that those cancel out. So we have 2.8 equals S times S plus 1 over X plus S. So we can just take X from here, right? So X plus S is, we change those around, and that's going to be S times S plus 1 over 2.8, meaning that X by itself is going to be this minus S, of course. So X is going to be equal to S times S plus 1 over 2.8 minus S. Okay, so remember that this X value here is supposed to be a fraction. Well, not only is it supposed to be a fraction, but it's supposed to be a number less than 1. And why is that? Well, because X refers to the ratio between the sunny portion of the distance over the whole distance. So it doesn't really make sense to say that the sunny part of the distance is bigger than the total distance itself, right? So clearly AC over AB has to be some number between 0 and 1. And actually all the fractions shown in the answer, in the choices, are all between 0 and 1. So we can't actually cancel out anything just from that. But the other thing we could try to do is we can use the fact that the average speed is 2.8. So this most likely means that the speed of the person, S, is somewhere around 2.8. It could be 2, it could be 3. So let's actually try out a couple of values. Let's first try S equals 1, right? Because we know S is an integer, so we can try a few things and see what happens. So if S is 1, then this is going to be 1 multiplied by 2 over 2.8 minus 1, right? So that's 2 over 2.8 minus 1. And well, this is going to be negative, so it doesn't really work. So let's move on to s is equal to 2. So if s is equal to 2, then x is going to be 2 times 3 over 2.8. Maybe I should make this into a 6 just not to confuse the multiplication sign with the decimal point. And this is minus 2. So let's see. This is the same as 60 over 28 minus 2. And then we can bring things to the same denominator. So that's 60 minus 56 over 28, which is 4 over 28 or 1 over 7. Right? And if you look at it, that's the same as answer E. But let's actually try one more and let's see if we can get anything else out of this. Let's say that the speed is 3. Okay, so if the speed is 3, then x is basically 3 multiplied by 4, which is 12 over 2.8, and then minus 3, which is 120 over 28 minus 3. And we bring things to the same denominator, so it's 120 minus, and this is going to be 84 over 28, and then this will give us I think 36 over 28, which is, as you can see, it's greater than 1. So you can convince yourself that all the s values from this point onwards are going to keep increasing and are going to be all greater than 1, which makes no physical sense. So the only correct answer in this case is found when s is equal to 2. And if that's the case, then Derek will travel a certain distance, and the ratio of the sunny portion to the total distance is 1 over 7. So if he travels 1 kilometer under sun, then there will be 6 more kilometers with clouds. So just as an example. So if 1 kilometer is sunny, then he will encounter 6 kilometers of clouds, which makes up to 7 kilometers total distance, which is why you have 1 over 7 as the ratio. And that's the end of the question.